Hello all, my name is Deep Ranjan. A very good morning to all of you. So this is the part 2 of the American Sign Language project. Okay, as I already told you, we are going to implement a complete end-to-end project in a very much detailed way. So this is the second part. So in this part we are going to understand about the model training, how we are going to set up a particular environment for the model training and all that. So as we already learned in the previous video that what is our problem statement and what kind of a dataset that we are going to use. Even I have shared the dataset link in the description, you can check there. Okay, so fine, now come to the model training part. Okay, so what I have done here, before going for a model training, what you have to do, just go to the Collab. Okay, open your sorry, not Collab, go to your drive. Inside a drive, make a particular directory with the name of American Sign Language. You can choose any name, whatever you want. I don't say anything about that. So I have chosen a data. I have created a directory with the name of American Sign Language, and everything, whatever things I have to do for the model training, I will do inside this particular directory only. Okay, so what I did here, I have created one this Collab file here by using just do a right click more, and you have to just scroll down, and this Google Collaborative, you have to just click on that, and there will be one new Collab file will be open just like that. When I click it, so it will redirect to the next page and the Google Collab will open. Okay, so just skip it. Okay, so anyhow, I am going to provide you this Collab file, okay, that I am going to use for this particular project. Okay, so each and everything is mentioned in that particular Collab file as well, like how the model training will go. Okay, so now comes to that Collab file model training part. So this is, so now comes to the model training part. Okay, so I have used here Yolov4-tiny model for this particular project, and it is working perfectly fine. Even I have already trained my model and I got a accuracy of 91%. Okay, so it's a pretty good model, okay, that I am going to tell you. So first thing what you have to do, you have to connect your Google Colab with that particular drive link. Okay, for that what you have to do, when you open this Google Colab, Colab file, then what you have to just click on that, and there will be a cell will be active. You have to just click on that and it will give you a link, and after that you have to just open that link and you have to select the particular email ID or drive, you can say, in which drive you have to make a folder of this particular name, and it will give you that link, and you have to just paste that link here and you will be connected. Okay, and after that what you have to do here, let me stop that interrupt execution. Okay, so that is fine, this fine. And after that there is a next step, you have to connect. Okay, you have just, by using this command, you will just connect your Collab with that particular Google Drive link. Okay, and inside that Google Drive you have created a particular directory. Inside that you have to do everything, right? So for that I have imported a OS here, and inside the root I have given the path of that particular directly. The same way, like you can click on this sample, so there are multiple files are there, so just need to click on that and copy path. In the same way, when you connect with the drive, so there will be a my drive kind of a file will be there, and you have to just click on that, expand it, and you will reach to that particular directory, and you have to just copy the path. Just right click and the copy a path, and you have to just mention there the path, and you are good to go. Okay, and os.ch directory that we are going to move in this particular directory. So our root directory is this one now. Okay, and whatever things we are going to do this in this particular directory only. Okay, fine. So now what I'm checking here, which version of NVIDIA I'm using here, so whether I'm using NVIDIA here or not. So for that what we have to do, we have to check the runtime. Okay, so this runtime should be GPU. Okay, then only it will be just your Google Colab will be connected with the NVIDIA driver. Otherwise in CPU and TPU mode it won't get the NVIDIA driver, CUDA driver, you can say that. Okay, and then we are checking which driver exactly we are getting. Okay, so I am getting the GPU of Tesla T4. So I will suggest you, if you are going for the model training from the scratch, okay, so I would suggest you just use this Tesla T4 GPU, because Collab is performing multiple GPUs. Okay, one is Tesla KT and one is Tesla P4. Okay, so even those DPUs are good, but their compute capability is very low, like 3.5 or 3.7 is there, but the Tesla T4 that is having the compute capability of 7.5. okay, so your model training will be fast as compared to that particular GPU. Okay, so I would suggest, please check this line, okay, which GPU your Collab is going to use. If it is not showing Tesla T4, what you have to do, you have to go to the runtime and you have to do factory reset runtime. Even though it is not working, then you have to do a restart runtime. Just do it a couple of times and you will get the you will see some changes in the GPU as well, because sometimes it is not providing the Tesla TPU. Okay, but mostly you will get the Tesla TPU only, nothing else. And then after that, this is the code of the YOLO4. It is checking like which GPU the cloud the NVIDIA is providing. So it is just this code is provided by the Yolov4-tiny team, okay, whichever they have implemented. Okay, so they will check with GPU. So I am using here the GPU type is Tesla T4 and their compute capability is 7.5. So it's a 7.5 exactly, but it is showing 7.5. okay, so it's 7. And then the main thing, so we have to clone a repository, Darknet Repository. Okay, so in this repository, all the codes and the models, all the direct training files and everything will be kept inside this particular particular git file. Okay, so just need to clone it. When you clone it, so you will see inside your directory there will be a folder with the name of Darknet will be created. Okay, when you clone this, okay, it will be created, and inside that you will see multiple files will be present there. So by default it will come. Okay, so this kind of a files you will see, it will come there. Then comes to the next step. So this is the next step. First, after creating this particular cloning this git repo, you have to go inside that Darknet directory, and then what it will do, it will just compile the Makefile. So what exactly it is doing? So Makefile, you can consider it as a requirement file. Like even in our any deep learning project, what we are doing, we are first creating one environment, and after that we are installing all the packages. So Makefile is something like that only. It is going to create a particular environment for your model training. Okay, model. So and it will install all the required files, required packages. So you don't need to install any other extra packages for the model training. So that will take a couple of minutes or even more than that for do that. Okay, even in my case it was taking yeah, I guess 101 seconds, so almost 2 minutes it take. Okay, and then what we have to do, we have to go to the root directly. First we are changing our directory to root, and then again going to the Darknet folder, this particular Darknet folder. So whatever things we are going to do, we will do inside this particular directory only. Okay, we don't need to go anywhere. Okay, and inside that Darknet, what we are going to do, we are just downloading the pre-trained weights. So Yolov4-tiny pre-trained weights are there. Okay, and these are the GitHub link for that. So you just need to download it by using the command wget and then this weights. Okay, so just need to run this command and it will automatically download those weights and it will save inside this particular directory with that name as well. So I will show you this name, this Yolov4-tiny weights and Yolov4-tiny convolution 29, because convolution 29 means Yolov4 is having 29 convolutions layer, so that's why its name is Yolov4-tiny.convolution 29 it is given. Then what we will do, we'll just checking the path where exactly we are. So we are inside this particular Darknet folder. Okay, and now this is the main thing. for custom training, like we are doing here custom training, right? So for custom training these things will be necessary. Okay, so what in the first line what we are doing here. Okay, one second, I have to explain you where you have to keep that data set as well. Okay, so as I showed you shown you the data set. Okay, this is the data set that I have kept here. So this is the zip file, so you don't need to do anything here. So you have to just unzip this particular folder. Okay, and inside that particular folder 3 folders are there: train, test and validation, and that will be kept inside the darknet folder only. So that's why I have kept this zip file inside this darknet and I have unzipped it. Okay, so these are the folders: train, test and validation. These 3 folders are present there, and inside each folder images and with their annotations are there. Okay, just wait for a couple. Yeah, you can see that even darknets of labels is there. So inside darknet.labels all the class names are mentioned there. So in the first steps, what we are doing, we are checking inside the train folder. This is the train folder, right? And inside that darknet labels, we are copying the number of, like, whatever things are present in this darknet.label. Okay, so we are just copying it in the data.obj names. So data is a particular directory inside this darknet folder, so you can see that there. Let me show you that as well. So yeah, see, so this is the data. Okay, yes, and inside that there will be a file with the name of obj dot names, I guess. Yeah, this is the file. Even I guess I won't be able to do that. Okay, so no issue, you just download this file. I'll show you. Let me download it as well. Okay, I'll show you what kind of things are mentioned there in this particular file. Just wait for a second. Okay, so you can see that A, B, C, D, E, F, G, H. So these 26 labels, like 26 classes are present in this project. Okay, that is the thing. And after that, what we are doing here, we are making a directory with the name of data. Okay, inside data we are making a directory with obj. Okay, inside it there is a obj directory is there, and what we are doing in this obj directory, we are just copying our all images that is in the train file and the validation file, even their annotations. We are just copying all the files present inside the train and the validation folder and kept it inside the data oblique obj. So inside data obj folder is there. We are just copying all the files present in the train and the validation inside that obj directory. Nothing else we are going to do. And after that, what we are doing here, we are opening a obj.data, that is a file name. Okay, and inside that we are mentioning the number of classes we have. We have a 26 number of class, and also providing the path of the train and text. Okay, sorry, the train and validation files. So data, inside data train.txt is present. So train.txt, inside train.txt there will be a specific path for each images. If I can show you, okay, let me show you that as well. Let me download it. Okay, because you won't be able to see it here, so I have to download it. Okay, so you can see that the path of that particular image is mentioned here. Even their annotation files are also there, I guess. So no, there is just a image. Okay, image path is not, like inside data obj folder is there, and inside that the image name is there, right? So this kind of things are mentioned there inside this. Okay, and same for the validation it is doing, and inside names it is just mentioning the names. Okay, whatever classes names are there, like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, and inside the backup there is a backup folder. So inside that backup it will store all the model that will be all the weights. Okay, after training, like usually YOLO4 started saving weights after 1000 iterations. Okay, so after each 1000 steps, okay, it will start saving your weights, okay, for future. And after that, what we are doing, we are just importing OS, and inside we are checking like data train, and also we are mentioning this was the file, and inside that file we are just mentioning this particular location, nothing else we are doing. And same for the validation we are doing. You have to just run this particular folder, okay, everything will be done itself. There is no need to do any hard coding inside that. And this is the main thing, that CFG file. Before model training we have to create a CFG file as well, okay, for a Yolov4. So inside that CFG file we have mentioned something like number of classes, and how many number of iteration we are going to use, number of batch size, this kind of things we are going to mention here. So you can see number of classes, number of batch size, steps 1, steps 2, this kind of things just we have to mention there. Everything is by default, just need to change the this one, batch size, okay. So just need to change. Actually I am training this model for just 20,000 steps, so because the number of classes we are having 26 into 1000, so it's a 20,000 steps we are going to train our model, okay. Even, and after that there is a detector file, CFG. Inside CFG file is there, we have mentioned the batch size of 64, subdivision 24, image height and width we are going to take 4x6, 416, and the number of channels 3. That means I'm going to deal with the RGB images, and these things are by default coming with that. So only thing we need to see about these things, okay. There is no, and also I have commented this testing, batch 1 and survey. These things we'll use for the testing purpose, like prediction purpose. For model training we need just these 4 things that we have to modify every time when we go for a custom model training, and rest of the things will be default. There is no need to change anything inside that, okay. When our CFG file will be ready, we have to just run it, okay. Just wait for a second, I think my screen got stuck, just a second, okay. Yeah, that's fine. So after that I'm just doing a cat operation. So what it will do, it will just show after editing what kind of things is mentioned there. So bash 64, subdivision 460, this kind of things are present inside my Yolov4-tiny detector.cfg file. Now time for the model training. So inside this model training, what we are going to use, so first we'll use this Darknet, okay. Inside that Darknet there is a you can say the method detector, and inside that a train is there, okay. And for that we are passing couple of values there. We are passing here data, okay. So data obj.data is there. So inside that data I have shown you what is mentioned inside .data. So inside that data I didn't show you, okay. So inside that obj.data, now let me show you what is mentioned inside this obj.data. Just a wait of okay. So inside the data mentioned, it is class name, train.txt, validation.txt, okay. obj names, the path of that one, and the backup where we have to store the model weights. Everything is mentioned there. And after that, what is this CFG file we have to mention, okay. And after that we are passing here that pre-trained weights that we are going to use here, and don't show, and the map is just for this kind of a result, like a verbose thing. So once you just run this file, this kind of output it will start generating after each. So I have trained this model for close to 5500 epochs, sorry, not epochs, iteration, and in that many iterations only I got the accuracy of 91.13. the best one I got was 91.13, okay. So that is in for this video, okay. Even when your training got stopped, okay, so there is a concept of resume training as well. So you can start your training from that particular weights that is going to, but at least your model should run till 1000 weight, then only you will be able to start the resume, okay. Otherwise it won't work. You have to start it from scratch, not a scratch, from the beginning, from one iteration. So that is the model training part, okay. So in the next video we'll try to see the model prediction, how our model is going to perform and all that. So thank you guys, bye bye.